Let's discuss the concept equilibrium of a particle. So what does the definition says? It says that if the net external force acting on a particle is zero, then the particle is said to be in equilibrium. I'll give an example to explain this. Let's take this to be point O, a particle at point O, and the forces at point A, this force be F1 bar, this to be F2, this is point B, and this is C, F3 bar. Okay, so I'm taking a point at O, particle at O. The three forces F1, F2 and F3 are acting on the particle. So according to the definition, if the net external force acting on a particle is zero, then the particle is said to be in equilibrium. So what do I write? F1 plus F2 plus F3 is equal to 0. It's very simple to understand this. Now let me prove it with the help of a parallelogram law of addition. Let's do that. So I draw an extension. So I draw a projection, perpendicular projection here. I'll draw a perpendicular projection, and here also I'll draw a perpendicular projection. So what is this point? The meeting point, let's take it as D. Now I draw a line from O to D. So what is this force? This is OD bar. So OD bar, according to the parallelogram law of addition, OD bar is what? This is what? This is F1, this is F2, this is F2, this is F1. OD bar is equal to F1 plus F2 bar. Now, if this particle have to be in equilibrium, we have already calculated OD bar is equal to what? F1 plus F2. This should be equal and opposite to F3, that is OC bar. So I take this as OC bar is equal to what? F3. If this particle have to be in equilibrium, that is the net force acting on the particle should be equal to 0, that is OC bar is equal to minus OD bar. This, why am I writing minus? Because it should be equal and opposite to OC. So this turns out to be F3 bar is equal to minus F1 plus F2 bar. Now if I rearrange this equation, what do I get? F3 plus F2 plus F1 is equal to 0. Or you can write this F1 plus F2 plus F3 is equal to 0. Now we need to know one point, that the three forces are called as concurrent forces. Why do I call this concurrent forces? Because if two or more forces act on the same particle, then we call it as concurrent forces. So in this, what did I do? I just proved that F1 plus F2 plus F3 is equal to 0 by using the parallelogram law of addition. So let's go to the next concept, that is Lami's theorem. What it says, if three forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle between the two forces. So I'll draw a similar figure here. So let's do that. So this point O, let's take this as, this is point C, this is F3, let's take this as, this is A, this is B, this is F1, this is F2. What does the Lami's theorem says? That is, if three forces acting at a point are in equilibrium, so F1 plus F2 plus F3 is equal to 0. Then each force is proportional. Each force means I should take the magnitude of the force. It is proportional to the sine of the angle between the two others. That is, F1 is proportional to sine of the angle between the two forces F2 and F3. The same way, F3 is proportional to sine of the angle between the other two forces. Let's take it as gamma. And what is the other force? F2 is proportional to sine of the angle between the other two forces. Let's take it as beta. So I can write this as, that is, magnitude of F1 is proportional to sine of the angle between the other two forces. What is it? It's alpha. The same way, F2 is proportional to sine of the angle between the other two forces. That is, what is the angle? It is beta, sine beta. Then what are the other forces we have? F3 is proportional to sine of the angle between the other two forces. What are the other two forces? F1 and F2. We can write this as sine gamma. So this can be written as F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. This is Lami's theorem. Now we'll go to the next concept.